Hi everyone, this is Mr. Zarzak. We're back down in the basement, which means it's time for another edition of Physics Underground. In this episode, I'm going to show you two really cool circuits, and then I have a challenge for you. So, let's get to it. Alright, so nothing makes me happier than seeing somebody be really clever and take some high school physics and use it to engineer something brand new and interesting. So the way that this works is the key piece is this blue piece. This is going to be our power supply. So there's a little on-off button here, and so it plugs in, so we can turn it on or turn it off. Okay, and it's connecting to this blue piece somehow. That is what's important. For any of the pieces, the order in which we connect them doesn't matter. So I could put this one in or take this one out. Okay, and there's all kinds of crazy configurations that we can do with this. All right, so you could spend a lot of time playing around with this, but what's important is that for each of these pieces, okay, is what's going on the outside. See, so there's a conductive strip that runs along the outside edge on both sides, and that's really the key. See, because like if I take the little square, just keep it simple. Okay, as long as I make contact with any one of those sides to the two metal parts on the blue, I'm going to get it to light up. Like if I try to do it this way, you'll see that it actually turns off, because really what's happening here is I'm short-circuiting it. Because what's really going on here is that this is our power supply, and these two strips that go around, these are our two terminals. So one of these is positive, one of these is negative. I don't know which one it is, and honestly, it really doesn't matter. See, the polarity makes no difference as long as I make contact between these two strips here and these two strips here, okay? And so what we're really looking at is just a really clever application of a parallel wiring. So each one of these just provides another branch. And so if I just stack them up this way, I don't know how high I can get these to go up before they would be off balance and fall over, okay? But you can see as long as I make connection there, I can really do this in any combination that I want. All right, I can even wire up multiple in parallel this way. And so I've got two different branches where as long as I make sure that it's the two sides to these two metal parts that make contact, it's just like adding another light bulb in parallel, because really that's what I'm doing. Okay, if I go across, well then I'm just shorting out the whole thing. All right, because really I'm just providing a path for charges to flow back to the power supply. That's not through any of the light bulbs. All right, so really, really cool application and really, really simple. All right, so now what we're looking at is an ordinary bathroom vanity light, but the physics team has gotten together and rewired it. All right, so these are all 4 100-watt bulbs, so they're all the same power, and yet in this instance, they do not have the same brightness because they're not being allowed to put out their maximum power because we've done some rewiring. All right, and so this is our challenge to you, which is you need to go ahead and figure out how we've rewired this based upon some testing that I'm going to show you here in just a moment. All right, and so what I'm going to do is first I'm going to turn off the room lights, because what I want you to see is that, believe it or not, all 4 of the lights are actually on right now. Okay, obviously this one over here on the right is the brightest. All right, but if I go ahead and I kind of isolate the bulb, just so you can see that the 2 bulbs in the middle, really they are on, they're just very dim. The one all the way on the left is a little bit brighter than the 2 in the middle, but certainly nowhere near as bright as this bulb here on the end. Okay, so for reference, this is bulb number 1, this is bulb number 2, this is bulb number 3, and bulb number 4. So just like we did in the series in Parallel Lab, I'm going to go through and I'm going to systematically take out different combinations of light bulbs, and your job is to determine the circuit diagram from this just based upon the behavior of taking the different bulbs out and these initial observations. Okay, so let's go ahead and get started with that. All right, so first I'm just going to unscrew bulb number 1. Okay, so now bulb number 1 is disconnected, and you can see what's going on with the other 3 bulbs. All right, so now I'm going to go ahead and I'm going to put bulb number 1 back in. All right, now I'm going to remove bulb number 2. Okay, and so you can see the behavior here, and just so that it's obvious enough so you can see it, if I isolate out here, okay, bulb number 3 is not lit. Okay, so again, this is with bulb number 2 removed. So let's put bulb number 2 back in. Okay, and now I'm going to take out bulb number 3. Okay, so now bulb number 3 is out. And again, just so you can see it, I'm going to isolate out bulb number 1 so that you can see that bulb number 2 is also out as well. So we'll put bulb number 3 back in. Okay, and now I'm going to take out bulb number 4. Okay, so that's what happens when we remove bulb number 4. Okay, so now everything is back in. So we're going to take out bulb numbers 1 and bulb number 2. Okay, so 1 and 2 are now out. We're going to put back in bulb number 2, but we're going to remove bulb number 3. Okay, so now 1 and 3 are out. Now I'm going to put bulb number 3 in, and I'm going to take out bulb number 4. So now we've got 1 and 4 are out. Okay, so now let's go ahead and put everybody back in. Okay, there we go. All right, so now I'm going to remove bulbs number 2 and bulb number 3. Okay, so 2 and 3 are out. Now I'm going to put number 3 back in, but I'm going to take out bulb number 4. Oh, excuse me. Sorry, we've got, scratch that. We've got bulb number 3 and bulb number 4 out. There we go. That's the test. Okay. All right, everybody's back in. Okay, so bulb numbers 1, bulb number 2, and number 3 are now out. So we're going to keep out 1 and 2, but we're going to put back in 3 and take out number 4. All right. So 1, 2, 4 are out. 3 is the only one in. All right. So then we're going to leave out number 4. We're going to take out number 3 and put in bulb number 2. So 1, 3, and 4 are out. 2 is in. We're going to have, we're going to have 2, 3, and 4 out, and only bulb number 1 in. And finally, all 4 bulbs are out. Okay, so now I've gone through and I've tested every possible combination. All right, you see a lot of them at the end. We had a whole bunch of nothing. All right, so now the challenge is to figure out, how did the physics team rewire this? What is the correct circuit diagram that leads to this funky behavior? All right, good luck on your challenge. All right, everyone. That brings us to the conclusion of another episode of Physics Underground. Thanks for watching, and we'll see you next time.